Alrighty folks, today we're going to be discussing the difference between a short circuit and a ground fault. After reflecting on the last video, I determined that I need to be less robotic and add a little bit more personality to my videos. You know, this is only video 3, we're getting there, we're learning. We're trying to figure this out as we go. So here we go. Let's start off with short circuits. Short circuits are not defined explicitly in the NEC. Surprising, I know. I totally expected it, and I was shocked, pun intended, to find out that short circuits are not explicitly defined in the NEC. A short circuit typically refers to when conductors of different potentials inadvertently make contact. This can typically be caused by insulation failure, miswiring, a device failing, or simply two wires being cut, making inadvertent contact, the usual. To summarize, a short circuit is when an ungrounded conductor, the hot conductor, makes contact with another ungrounded conductor or a neutral. Let's move on to ground fault. The definition of ground fault is an unintentional electrically conductive connection between an ungrounded conductor of an electrical circuit and the normally non-current carrying conductors, metallic enclosures, metallic raceways, metallic equipment, or earth. To simplify, a ground fault happens when an ungrounded conductor, the hot conductor, makes contact with anything that is grounded. This could be the case of a grounded device or appliance. This could be a ground wire. This could be a grounding electrode. This could be a metal electrical enclosure or a box. All of the above. If you guys are a bunch of wire lickers like myself, if I'm touching an enclosure or a piece of conduit that's bonded, and I decide to use my built-in electrical tester, decide to taste the sparks, that would be a ground fault because the current would be flowing from the source, through the conductor, through me to ground. Key differences to note. Short circuits, hot to hot or hot to neutral. Ground fault is hot to ground. That simple. Okay, so why am I making this video? I know this seems pretty elementary, but truly understanding the difference between faults is required. It is necessary in order to be effective in service. You really have to know the what in order to find the why. In order to truly diagnose efficiently and to be as effective as possible in the field, you need to know your terminology. You need to know the different causes and sources of faults, especially when it comes to basic things like overcurrent faults. Another video I have breaking down simple fault definitions is my overload versus overcurrent video. It's a little bit dry because, you know, I'm kind of new and it was pretty dang scripted, but got some good information. So if you guys are at all interested, check it out. Have a great day. Stay sparky.